in this lecture now we will look at Fry's rearrangement, right? This rearrangement occurs in esters of phenol, right? Like we have esters in your alcohols. When alcohols react with carboxylic acids or your acid anhydride, right, or acetyl chloride, they form esters, right? Similarly, your phenols can also form esters, and those esters in presence of aluminium chloride, right, will undergo a rearrangement reaction, an intramolecular rearrangement reaction. That is, this rearrangement occurs within the molecule by shifting of groups, right, from one position to another position, right? So in presence of aluminium chloride in esters of phenol, the acyl group will migrate from phenolic oxygen to your ortho and para positions, right? This is how it goes. So let's first quickly see how esters of phenols are formed, then we will see how the rearrangement will occur in the esters of phenol, right? Let's say for any general reaction, let's say any acid chloride RCOCl, right, will react to form this compound. This is an ester, and this R can be CH3, right, CH3CH2, any alkyl group. This is an ester. Now what Fry's rearrangement says, that this ester will undergo a rearrangement, right? And as per the rearrangement, this rearrangement takes place in presence of aluminium chloride, right, at a temperature of around 412 to 423 kelvins. At this temperature and in the presence of aluminium chloride, the acyl group, right, this acyl group will migrate from this phenolic oxygen, like I said, to the ortho and para position of benzene ring, right, to form ortho and para isomer, right, OH COR. This is your ortho product plus your para product, ortho and para product, and this one would be more stable. This one would be, the ortho would be in major quantity, right? This would always be in major quantity and this would be in minor quantity, but at higher temperature this ortho isomer can be in major quantity, right? So this is your ortho and this is your para. Now let's look into the mechanism of this reaction, how this reaction occurs. Now just remember one thing in these two reactions. This reaction is the formation of ester of phenol, right? We call this reaction as esterification. Esterification, right? And in this esterification, if you look at this position, this acyl group is introduced. RCO group is introduced here in this compound, right? So this reaction is also known as acylation, right? So this rearrangement occurs due to this rearrangement, this Fry's rearrangement mainly occurs, the probable mechanism of this reaction is it occurs due to acylium ion. Acylium ion is your RCO, this ion, right? This reaction occurs due to this acylium ion. Now let's see how in the mechanism it forms, this acylium ion is created or formed. This is your, again, your phenol, right, sorry, your ester, right? It says in presence of aluminium chloride. We know that aluminium chloride is electron deficient compound, right? And because this is an exception to octet rule, so this is electron deficient. What it will do is, we know that oxygen has two lone pair of electrons, so this aluminium will associate through this lone pair with this oxygen atom, right, forming this complex kind of a compound, which is AlCl3 COR. Right? Now this complex will lose this acylium ion, right? And this acylium ion will attack at ortho and para position of this benzene ring, right? This is how it will occur. O AlCl3, right? Now it will lose this acylium, like let's write it as RCO. We know that C and O has double bond, right? And here you have a plus sign, right? Because this is electron deficient, so you have a plus sign. So now this will attack at ortho and at para position to form these two compounds. Right? Now let's see first how it forms. It will attack at ortho position to form RCO. Here you have AlCl3, O and AlCl3. Now you have Cl3, Cl2, let's write it like this. Now this Cl and this H at this ortho position, right, will react, right, to lose an HCl molecule. Here it will look like this, AlCl2, right, plus AlCl2, then you have RCO here, right? This is the type of compound that gets formed when HCl molecule is lost, right? So now it would be like this, AlCl2, right? So this now will undergo hydrolysis to form OH, right, and RCO you have here already. This is the product. This is your ortho product, right, that gets formed. Right. Similarly, when this RCO attack at para position, you will get this para product, right? And the and it's same, right, with that. Right. Now if you want a para product, let's see it from here. AlCl3, it will attack here, RCO, right? Now this H and 1 Cl from here will lose HCl, O, AlCl2, right, plus RCO, sorry, RCO, right? Now this will undergo hydrolysis, RCO and OH. This is your para product. This is your ortho product. This is your para product, right? This is ortho, this is para, and this is your Fries rearrangement, right? I repeat, this is an ester of phenol, right, which in presence of aluminium chloride and at a temperature of 412 to 423 will undergo rearrangement to form ortho and para product. In ortho, this acyl group will migrate to this ortho position and to para position to form these two products. And if you look at this mechanism of this reaction, this is the probable mechanism of this reaction, where in this aluminium chloride will associate here, right, and it will form this compound, this complex compound, which will lose this acyl group, right, and this acyl will then attack at ortho and para positions, right, and with this HCl will be removed, right. Now this is formed, right, which on hydrolysis will give you this product, right. I hope this is clear. Thanks.